Welcome to the deep dive. Today, we're shifting gears quite a bit.
Yeah, big shift.
We're looking at how artificial intelligence, AI, is really changing space exploration and how we look at Earth.
That's right. And this came from you, our listener. You shared some fantastic sources.
Yeah, really interesting stuff. Two pretty deep research papers on AI in space, and also this great piece from NASA itself.
All about how AI is helping out the Mars rovers, like right now.
So our mission here, for this deep dive is to pull out the really fascinating bits for you.
Exactly. We want to give you a solid sense of how AI isn't just like a future concept, but a tool being used today.
Uh-huh. To explore space, understand our planet better, it's
Hmm.
pretty broad.
From landing on the moon safely to finding new planets and tracking climate change.
Okay, so let's jump right in. That safe lunar landing idea, that sounds like something straight out of sci-fi.
It does, but it's very real. The research
Okay.
makes it clear. Landing isn't just, finding a flat spot.
Yeah.
AI algorithms are absolutely crucial now. We have to analyze just tons of data from different sensors.
To find the absolute best place to touch down.
Precisely. And they're looking at the slope, how rocky it is, the lighting conditions, all in real time, basically.
Okay, so what kind of sensors are feeding the AI this information? What's the tech involved?
Oh, it's quite a suite of tools. You've got LiDAR, which uses lasers for really detailed 3D maps.
Okay.
Then radar, that goes deeper, right? Looking at the surface composition, what's underneath.
Mm-hmm.
And visual odometry, that's like giving the lander smart eyes. It uses cameras, stereo vision to figure out its position and movement.
Like how our eyes judge distance.
Sort of, yeah.
Mm-hmm.
Plus inertial navigation accelerometers, gyroscopes like in your phone tracking movement and rotation to know where it is.
Wow, that's a lot of data streams coming in at once. How does the AI possibly juggle all that?
Well, that's where this thing called SLAM comes in, simultaneous localization and mapping.
Slam.
Think about walking into a dark room you don't know and trying to draw a map of it while figuring out where you are in that room.
Okay, that sounds difficult.
It is. But SLAM lets the lander do just that. It merges all the sensor data, the lander's motion, builds a map on the fly, and knows its exact spot on that map.
And it uses that map to classify the ground.
Exactly. Terrain classification uses machine learning to say, okay, this bit is rocks, that's a crater, this looks pretty flat.
Mm-hmm.
And then hazard detection algorithms specifically look for the dangers, big boulders, steep slopes, and tell the lander, avoid that.
So SLAM is really the work through, making decisions on the fly.
It's a huge part of it, yes. It means the lander isn't just following pre-programmed steps from Earth. It can react to what it actually sees right then and there.
Which lets it explore trickier places.
Definitely. More complex, unpredictable terrain becomes accessible.
It's like having a super fast, super aware pilot right there on board. Okay, so landing is one thing, but our sources, they talk about AI being used much more broadly in space.
Oh, absolutely. That research paper, the one from the International Journal of Techno-Engineering, it really hammers home how wide-ranging AI's impact is.
Like what?
Everything from, smarter robots and autonomous vehicles to just handling the sheer volume of data we get back.
Right, the data processing must be immense.
Huge. And even things like natural language processing, making communication more intuitive. There's just a massive amount of interest and work going into AI for space travel now.
So it feels like researchers are specifically using AI to tackle the really hard problems of working in space.
That's exactly what the paper suggests. It breaks down the challenges into basically three areas.
Sure.
Mission planning, the whole design and execution part,
Yeah.
then the actual space exploration itself, and really importantly, Earth observation using space to understand our own planet.
And the paper outlines AI solutions for these.
Yeah, it goes into specific AI approaches that are being developed or are already in use for those exact challenges.
Okay. So AI is involved from the drawing board right through to analyzing planetary data. Now, some of the AI terms themselves can sound a bit technical. Can we break down a few key types?
Sure, let's try. Unsupervised learning is a good place to start.
Okay.
Imagine you have a massive box of photos, totally unsorted. Unsupervised learning is like an AI that can look through them and automatically group similar photos together. Maybe all the landscapes here, all the portraits there, without you telling it what the categories are beforehand.
So it finds patterns on its own.
Exactly. Techniques like k-means clustering do this. It's great for finding hidden structures and unlabeled data,
Hmm.
like grouping types of galaxies or identifying different kinds of land cover in satellite images automatically.
And dimensionality reduction. That sounds useful for space data.
Very useful. It's like taking a super complex spreadsheet with hundreds of columns and finding a way to boil it down to just a few key columns that still capture most of the important information. It simplifies complex data without losing the essence.
Got it. Finding structure without labels. What if you do have some labels, but not many?
Then you might use semi-supervised learning.
Yeah.
It's clever. It learns from a small bit of labeled data plus a whole lot of unlabeled data.
Why is that useful?
Well, labeling huge data sets, especially in science, can be incredibly time-consuming and expensive. This approach gives you a good balance.
Makes sense. And what about the robots? How does AI make them more autonomous?
A big one there is reinforcement learning. Think of it like training a pet.
Okay.
The AI agent, the robot, tries things out in its environment. If it does something that leads to a good outcome, a reward, it learns to do that more often.
Learning by doing.
Precisely. Trial and error. It's perfect for robots operating in unpredictable places like Mars, where you can't possibly program for every single thing they might encounter.
Right, so they adapt. Now, neural networks, we hear that term all the time. How do they fit in?
Neural networks are sort of inspired by the brain's structure, right? Interconnected nodes, learning patterns from data. Convolutional neural networks, CNNs, are stars when it comes to visual stuff, analyzing images from rovers, identifying features.
And RNNs?
Recurrent neural networks, they're good with sequences, data that unfolds over time. Think tracking weather patterns or analyzing radio signals.
And deep learning. That seems to be everywhere now.
Deep learning basically takes neural networks and adds many more layers, making them deeper.
Okay.
This lets them learn really complex, abstract patterns. It's behind huge leaps in understanding language, recognizing speech, identifying objects and images,
Yeah.
all super relevant for space.
Right, and fuzzy logic. That sounds intriguing.
Yeah, fuzzy logic is cool. It deals with things that aren't just true or false, yes or no. It handles shades of gray, like sort of warm or mostly clear.
More like how humans think.
Exactly. It allows systems to reason with uncertainty, which is really useful for controlling complex spacecraft systems where conditions aren't always black and white.
Okay, that gives us a good handle on the AI toolkit. Let's talk concrete examples. Mission planning sounds like a prime candidate for AI help.
Oh, absolutely. Just managing the sheer amount of information procedures, past mission data, operational knowledge, it's overwhelming.
So AI acts like an assistant.
Precisely. One of the papers mentioned an AI called Daphne, basically an engineering assistant.
Daphne. Okay.
Yeah, it uses language processing and data mining to dig through archives of old missions, find relevant data, assess it, and present it to engineers. Saves incredible amounts of time.
So engineers don't have to spend weeks searching old reports.
Right. Daphne helped design Earth observation satellites by leveraging all that historical knowledge. It's like having the ultimate searchable mission database.
That's a huge efficiency gain. And AI is also sort of watching over satellites already up there.
Definitely. Monitoring satellite health is becoming key. You know, companies like SpaceX use AI to process sensor data constantly.
For what? Keeping them in place.
Yeah, maintaining position and, crucially, avoiding collisions with all the space debris up there.
Right, space junk.
And there's this Italian company, AICO, with their Mirage software. It actually lets satellites replan their own tasks autonomously if something unexpected happens.
Without waiting for commands from Earth.
Exactly. And we already mentioned Perseverance AI was critical for its landing and how it drives itself around Mars now.
It's not just about operating in space, though. AI is changing how we build spacecraft, too.
That's another interesting angle, yeah. AI can improve manufacturing through automation. Think collaborative robots, cobots, working alongside humans.
Why is that better?
It reduces human error,
Yeah.
which is critical, and it minimizes contamination in those super clean rooms where space hardware is built. Could make things faster, cheaper, more reliable.
And then there's Simon on the ISS, a personal AI for astronauts.
Yeah, Simon. Developed with IBM, it's this free-floating AI head that can talk to astronauts, pull up information, help with procedures, like a crewmate that doesn't need sleep.
Wild. Okay, so AI is involved from design to build to operations to astronaut support. Let's shift to pure exploration, pushing the frontiers.
This is where it gets really exciting, looking forward. The sources talk about AI being central to finding new astronomical objects automatically, making robotic explorers way more capable.
Improving navigation on other planets.
All of that.
Yeah.
You know, that first ever image of a black hole, the M87 one.
Yeah, incredible image.
Well, reconstructing that image from the telescope data relied heavily on a Bayesian approach. That's a statistical method with deep roots in AI.
Wow, I didn't realize AI was so involved in that. And finding things in all the telescope data?
Absolutely. AI is getting really good at classifying and recognizing deep space objects, like the discovery of those exoplanets, Kepler 80Gs and 90I.
Mm-hmm.
AI algorithms found them by spotting tiny, subtle patterns in the Kepler telescope data that humans had missed, patterns indicating planets orbiting those stars.
That's amazing. Discovering new worlds with algorithms. What about that space debris problem you mentioned?
It's a serious issue, and deep learning is being looked at to make laser tracking of debris much, much more accurate,
Better tracking means better avoidance.
or even potential cleanup strategies down the line. Better tracking is the first step. And NASA is working with Intel specifically on AI for navigating surfaces, like the Moon and Mars.
Right.
Plus, there's research into using deep learning and reinforcement learning for guiding whole teams of robots working together autonomously in space.
Okay, so AI is finding things, helping us navigate, and maybe even cleaning up our mess. Let's bring it back home. Earth observation. How is AI changing how we view our own planet?
It's becoming essential. AI models help us analyze incredibly complex Earth systems.
Like what kinds of analysis?
Classifying land cover from satellite images, forests, cities, water, farmland. Building better models of how the atmosphere interacts with oceans and land.
Finding anomalies.
Yes, detecting anomalies, extreme weather events, and even figuring out the cause and effect relationships within climate systems. AI can find subtle patterns in massive data sets that humans just can't see.
Giving us early warnings, maybe?
Potentially, yes, for climate impacts, natural disasters. It's a powerful tool.
So AI plus Earth observation can really help with big challenges, like the Sustainable Development Goals.
That's a key point in the sources, yeah. Using AI to process satellite data in real time can directly support those goals. And there's this trend towards processing data in space.
On the satellite itself.
Right. Instead of beaming down terabytes of raw data, the AI analyzes it on board and just sends down the results, the insights.
That's much more efficient.
Massively. It reduces the data bottleneck, gets information to people faster, enables quicker responses. Imagine real-time crop health alerts for farmers.
What AI techniques are common for Earth observation?
Deep neural networks are big here. CNNs and RNNs again, especially for hyperspectral images.
Hyperspectral.
Images that capture way more colors, more spectral information than our eyes see. They contain incredibly rich data about the surface. AI helps unlock that. Researchers are also building networks that look at relationships across an entire image, not just local areas, and using semi-supervised learning too.
And for disasters, how does AI help when things go wrong?
It's becoming vital across the board: mitigation, preparedness, response, recovery.
Examples.
During the 2017 Atlantic hurricanes, machine learning analyzed social media posts, Twitter, Facebook, to understand needs on the ground in real time.
Using social media data? Wow.
Yeah, using things like random forest learning, K-means clustering, and deep learning is used to analyze satellite images after a disaster to map damage quickly. There are even models using Twitter data to help predict floods better.
That's turning everyday data into life-saving tools. And we still need better Earth observation, right?
Always. Especially for things like monitoring land use, agriculture, food security, environmental changes. AI-powered imaging and these advanced learning techniques are really pushing that forward.
Okay, finally, let's dig into that NASA article about perseverance on Mars. How is AI changing the science it does?
So NASA talks about AI enabling adaptive sampling.
Adaptive sampling.
Yeah. AI helps the rover position its PIXL instrument, that's the X-ray one, very precisely on spots scientists think are most likely to hold signs of ancient life, biosignatures.
So the AI helps it zoom in on those types.
Exactly. It's not just random sampling, it's intelligently targeting the most promising areas based on incoming data.
And it analyzes the data from PIXL, too.
It does. In real time, it helps create these detailed mineral maps. And those maps help the science team back on Earth decide which rock samples are the absolute must-haves for potentially bringing back Earth.
That's a huge help for the Mars sample return mission.
A critical part of it, yeah. Making sure we collect the best possible samples.
Now, Perseverance wasn't the first rover with AI, was it?
No, Curiosity was the pioneer there. It was the first to use AI to autonomously choose rocks based on shape and color and zap them with its laser to check their chemistry.
Great.
Perseverance has that too, but its navigation AI is much more advanced. It can drive itself much further and faster without waiting for commands from Earth for every move.
But it's important to remember the human
Absolutely crucial point. The NASA piece stresses this. Despite the AI, human scientists and engineers do the overall planning, set the goals, interpret the findings.
AI is a tool.
A very powerful tool that lets them do more science more efficiently. But humans make the big decisions. And Perseverance's mission, remember, is all about astrobiology.
Searching for ancient life signs.
Yes, understanding Mars's geology, its past climate, preparing for humans, and collecting those vital samples for the joint NASA and European Space Agency return mission.
So wrapping this up, it's clear from all these sources that AI isn't just coming to space exploration and Earth observation. It's already here, and it's transformative.
Definitely. Safer landings, smarter missions, way better data analysis. It's enabling us to understand our planet and the universe in ways that were, frankly, impossible just a short time ago.
It really is. The speed of development is just incredible.
It makes you wonder, doesn't it, when you see what AI can do now across all these areas, what kind of space missions, what kind of discoveries that seem like pure fantasy today might actually be possible, maybe even soon.
Yeah, what new questions will AI help us answer about, our place in the universe or even the future of Earth itself?
It's definitely something to think about.
A lot to think about. We really hope you found this deep dive interesting and maybe it sparks some further exploration for you. Thanks for joining us.